2.3 is called Conditions of Parallelograms. And if you were paying attention yesterday to the properties of parallelograms, this lesson is going to be super, super easy for you because it's basically the same thing, just turned around backwards. So what they're going to do is they're going to give you a parallelogram and they're going to tell you some information about it, and you're going to determine, is that enough information to say, yes, it's a parallelogram, or no, it's not a parallelogram, based on its properties, okay? So the main thing that's going to happen is they're going to say, is it a parallelogram? And you're simply going to say, yes, it is, no, it's not, based on what they gave you, okay? Sometimes you'll have to say, no, they didn't give me enough information, okay? So remember yesterday there were special properties of parallelogram. First one had to do with the name. What about the name? Parallel. So you have to have opposite sides parallel, right? Okay. The first property had to do with the opposite sides as well. Not only are they parallel, they're also congruent, right? Okay. Then we went to the angles. And so there were opposite angles, and then there were consecutive angles. So the opposite angles needed to be what? Congruent, and consecutive angles needed to be supplementary. And then the last property had to do with inside the parallelogram, those diagonals. What did the diagonals do to each other? Bisect. Good. Okay, so we're going to be looking at those same things, and we're going to need to know, are they giving us enough information about the particular parallelogram to say, yes, it is, or no, they didn't give us enough information and it's not yet, or no, it doesn't meet the criteria, okay? So, first, your parallelogram needs to have, obviously, opposite sides parallel. So we're going to use those little carets. So little carets, right and left, I'll do single, top and bottom, I'll do double. But that just indicates that the opposite sides are parallel. If you get a figure and they say that both pairs of opposite sides are parallel, then yes, it's going to be a parallelogram. That meets just the definition of parallelogram. Okay, so that one would definitely be a yes. All right, the second condition would be that you would have one pair of opposite sides parallel. So let's pick top and bottom. But it could be right and left. And those two sides also need to be congruent. Not both, but just one pair. And then if you have that much information, you can say, yes, it's a parallelogram. Okay? It could be top and bottom, or it could be right and left. All right, the third condition. The third condition would be that you would have two pairs of congruent opposite sides. So top and bottom would be congruent, and right and left would be congruent. That would be enough to prove it a parallelogram. Okay. The fourth condition. Now we're going to go inside our parallelogram. The first three are all on the sides. The second three are going to have to be inside. So let's see. You're going to have, for condition 4, opposite angles need to be congruent. So this one and this one congruent, and this one and this one congruent. So put single arcs on opposites and double arcs on opposites. That would be enough to prove your parallelogram congruent. Okay? Condition number 5 also has to do with angles, and it's the supplementary one. So, if they give you an angle measure, let's say this one right here, they give you some number. Let's say they gave you that it's 100 or 80 degrees, right? One of its consecutive angles would need to be supplementary to it. Either this one or this one would need to be 180 minus x. Or it could be this one over here, 180 minus x. Just one of the two consecutive angles would need to be supplementary. So if this one was 80, then either this one or this one would need to be 100. Okay. And we've got one more, right? Condition number 6. Which one haven't we seen yet? Diagonals. So draw in 2 diagonals here to here. And if those diagonals bisect each other, then you will be able to say, yes, it's a parallelogram. So we'll single tick and single tick one of the diagonals, and then we'll double tick and double tick the other diagonal. All right, so let's see how those questions are going to be worded. So example number 1. You're going to be asked to show or prove that a parallelogram, and remember yesterday I told you could use this little shortcut, this little box, instead of writing out the whole word parallelogram, we'll call it JKLM, is a little box parallelogram. Okay? If you want to write out the whole word parallelogram, go for it. All right, so we're going to draw a parallelogram. We'll call it JKLM. And then we're going to go for some measurements. So the left side is going to be 15a minus 11. And the right side, LM, is going to be 10a plus 4. And then we've got the top and the bottom. So the top is going to be 5x plus 6. And JM, the bottom, is going to be 8x minus 21. Okay? And I'm going to give you some values. So given that A is 3 and X is 9. Move it up. Get that clutter off of there. All right, so one of our conditions, condition number 3, says that if we can prove that the top and the bottom are congruent and the left and the right are congruent, then we can say, yes, it's a parallelogram. And since we have all 4 sides marked with some information, that's most likely the one we're going to use, right? Because it didn't give us the condition satisfying 1, which would say they're parallel. There's nothing telling us they're parallel, so we're going to go with 3. Does that make sense? You guys see why we're going with 3? Okay. So do you want to do top and bottom first or right and left? Top and bottom. So let's do top and bottom first. And the top and bottom have x, so we're going to use 9. We're going to say that 5 times 9 plus 6 should be equal to 8 times 9 minus 21. Some of you are going to need to get your calculator out. But basically, 5 times 9 is 45. Add the 6, we get 51. On the right, we go 8 times 9, which is 72, minus 21 more, we get 51. Does 51 equal 51? Yes, so far we're good, right? That was top and bottom. Now we need to do left and right. The left and right have a, so we're going to plug in 3. So let's go 15 times 3 minus 11. Set that equal to 10 times 3 plus 4. And then go ahead and simplify. So 15 times 3 is 45. 45 minus 11 more is 34. And then on the right, we've got 10 times 3, which is 30, plus 4 more is 34. So does 34 equal 34? Yes, it does. So does this satisfy the conditions of a parallelogram? Is it a parallelogram? You say, yes, it is a parallelogram. And we used this third one, right? This third condition where both pairs of opposite sides are congruent. And we were able to prove that, yes, it is a parallelogram because it meets those conditions. Okay? I'm going to move this up. You'll see it in just a second. We'll look at one more. There are 6 conditions, so we're not going to go through all 6. Okay? We're just going to do one more example. All right? All right. Example 1 had to do with sides, so example 2 will go inside and look at the angles. We're going to draw, whoop, that was not the best parallelogram I've ever drawn. Let's try that again. There we go. All right. So we'll call this parallelogram PQRS. And let's get some information. Angle Q right here is going to be 6y plus 7. Angle R up here is going to be 15x minus 16. And angle S down here is going to be 8y minus 6. Okay. And I'm going to give you some information just like I did in example 1. I'm going to tell you that x is 10. And thank you.
Please excuse.
Okay, thanks.
Thank you.
Y is 6.5. All right, so see those angles? Do you think we're going to use opposites or consecutive? Consecutive, right? We do have a pair of opposites, but we also have consecutive. All right, so let's try consecutive. So let's start with angle R, the one in the middle. Okay, so we're going to take the 15, plug in 10 for x, subtract 16. So that's what? 150 minus 16. I got 134 degrees. Okay, now let's try angle Q. That one we're going to plug in for y. So we're going to have 6 times 6.5 plus 7. So 6 times 6.5 plus 7, I got 46 degrees. Just out of curiosity, what's 134 plus 46? 180. Do we like that number? Yes, we do. Okay. Just for double checking, let's try angle S. You jump over here and we've done angle S. We also plug in the y. We get 8 times 6.5. Subtract 6. I got 46 as well, which we already know is going to add up to 180. So we say, yes, this is a parallelogram because the consecutive angles are supplementary.